I'm just going to demonstrate how to use the PhET Colorado Circuit Construction Kit. You can set some of these up in advance, or you can just sort of leave them and show the class how you're doing it. So I'm just adding the components and slotting them in. I would suggest that you don't try and sort of fit your battery into a gap. You sort of add it as part of a sequence. Otherwise, you can end up with a slightly clumsy looking circuit. I'm going to bring my wires down vertically here. And I'll just pop a light bulb in. You can see there are two circles. Basically, you're always trying to match your wire to a circle. That means that I actually will have a little bit of a slope here, but now you can see I've got my electrons flowing around. Up in the top right hand side, I can change this from electron flow, which is, if you like, your negative charge, to a conventional current flow. I can include labels, or I can remove them. I can add values, so you can see that I've got 9 volts and 10 ohms. I can measure my voltage across a component by just placing the probes in different places. I've got 9 volts across there, and I've got 9 volts across the battery as well. And then when I'm finished, I just bring the voltmeter back. The ammeter is slightly odd. I don't have to break the circuit. I can just place that reader over the top of the wire. So that's slightly unrealistic, but it does make life an awful lot simpler. And then if I want to add more wires, for example, to make a parallel circuit, I can just do this as I'm going along. And I would suggest try and, as I say, keep this very square. So it's just that little bit simpler for your students to check. Maybe I want to change this bulb. I maybe change this one to 20 ohms. Okay. So now I've got 2 bulbs in different branches of my circuit, and they have different resistances. So what I will expect when I take my voltmeter, first of all, is I will have 9 volts across the battery. I have 9 volts across the top bulb, and I also, it's a little tricky to see, but I do have 9 volts across the second bulb as well. So that's one nice way of showing my series and parallel circuits. If I take my current, my ammeter, I have 1.35 amps going in and out of the cell. You can check that. I have 0.9 amps on either side of the bulb in the lower branch, so upper branch, I was saying. In the lower branch, I've got double the resistance, which means I've got half the current. Put that back away. I can break. I put that in the bin. I've got rid of that, and I'm going to add a switch instead. So that looks like it would have been better if I'd broken that. Again, I want to try and just stick to having quite nice straight lines in my circuit. I do think it's worth just that slight extra bit of fiddling around. And there we go. I've got my switch, and it shows it's got infinite resistance because it's open, and now when it's closed, it's got 0 resistance, as if the circuit's not in there. So that's one thing that you can do. You can change, put different items in and sort of check what they do to the circuit. And if you go to the lab, you actually have a much wider variety of things that you can use, and a few more activities. You can check your wires resistivity and your battery's resistance. So if you're using this, probably at A level is when you use the lab. At the introductory level, I think this would be absolutely ample for your students. And the other thing I would say is, if you are on the PhET Colorado website, make yourself an account. If you make yourself an account, when you sign in, you will be able to access a PDF and often a video that just shows you how the different elements or the different sort of simulations work.